So I'm going to go ahead and share my screen with you guys. There we go. All right, so this is what I've made up for today. I'm just going to go over this slide and then we'll jump over to D2L and talk about specifics about how you'll access stuff. So the Unit 2 exam, what's going to happen, you can see down here, I've got it written. The exam will become available on D2L starting on Friday, July the 5th, which is next week, at 12 a.m. All right, so what that means for you is that you have a little bit over a week to prepare for this exam. It's just a PDF. You'll be able to open it on your computer or on your phone or whatever, and then you will complete the exam whenever you have time at your convenience, and then you will turn it into the Dropbox on D2L by Saturday, July 5th. So you have a total of 48 hours in there to work on that. And let me just show you what it's going to look like. I was doing this.
Whoa, what happened to my audio? Hello? Something happened to my audio. I can't hear you, Dr. Berry.
Miss Berry, I think you're muted.
Yes. It's like, I thought it was me. Jesus. Okay. Hello?
Miss Berry.
Dr. Berry, if you're addressing us, we can't hear you because you're muted. I think she might be doing.
I can tell she's talking, but I don't know if she knows she's muted or not.
I'm back. I don't know what happened.
Okay. I see
It
Ansley
kicked me
raised her
out.
hand.
All right. I don't know what happened. Maybe when I tried to share my screen, I got muted. Okay, so, oh my gosh, it closed out. No, okay, here I am. Can y'all see and hear everything now?
Yes, ma'am.
Okay, cool. Did y'all hear anything I said?
No, ma'am.
Oh,
No,
great. Okay, so I'll start over. So the Unit 2 exam will start on Friday. It'll open up on Friday, July 5th, at 12 a.m. And you will either print it out and do it on paper, or you can copy it onto your own paper really neatly. Or you can, if you have like an iPad and you can write on the screen, you can do that as well. You have 48 hours to do the exam. And once you complete it, you will turn it into the Dropbox on D2L. And you just have to do that by Saturday, July 6th at 11:59 p.m. You must work on your own for this exam. You may use your notes in any of our other course resources. So if you want to rewatch videos, go back and rewatch this video. Speaking of which, I bet this isn't recording now. Let me start recording again. Oh, it was recording. Okay.
It shows that it is recording.
Yeah. Button going over there.
All right. So you can rewatch this video to help you. You can ask me any questions via email, but I just don't want you to communicate with any of your classmates about the exam. So once we get to Friday, July 5th, you will go here to D2L and you'll click on content and then go to unit 2. And at the very bottom down here, you can see you cannot click on the link right now because it's not, it hasn't started yet. But starting on Friday, July 5th at 12:01 a.m., you'll be able to click on this link. It'll open a PDF and you can start the exam. It's not timed. It's not, there's no recording or anything that's happening. You're not in a lockdown browser. You're just doing this on your own time. And then once you're finished,
if you're sharing something, we can't. Okay, there it is.
Do you see it?
Yes, ma'am. I see it now.
Okay. And once you're done, you're going to put it right here in this Dropbox. You can see it's not available yet either. And I also was mentioning when I was muted, I was also mentioning that we have this practice exam here, which is, we're going to be going over parts of that today. And once you complete the practice exam and you put your work into the Dropbox right here, the answer key will become available. So let me see if I can show you. So I have the answer key. Yeah, it's right here. And once you submit something to the Dropbox folder, this answer key will become available to you, and you'll be able to check your work. All right. So.
Okay, Dr. Berry, can I give back to you what I heard, and maybe I just want to make for my comprehension. Yep. So on the 5th of July, you will make it available, the exam available to us.
Right.
We have the option of printing it out or putting it in a Word document, whichever we choose to do, and then we would submit that to a box that you will have for us to submit it back.
The Dropbox. Yep.
So if we choose to print it off, do we need to scan it to submit it to you, or how does that go?
Yeah, you can scan it. If you have a scanner, you can do that. I use an app on my phone. It's free. It's called Adobe Scan, which I'm sure there's different apps, but you can also just take pictures of your work and send them that way as well. So a PDF, you can scan it, make it into a PDF, or you can just take pictures of it or drop it in that Dropbox.
Yes, ma'am. Thank you.
You're welcome. So let's see. The whole reason that I'm doing this test differently is because it's mainly proofs. I want to say that 50 out of 100 points on the test will be proofs. The exam is going to look really similar to the practice exam. It's going to follow the same order. And a lot of them I just went in and, I might have changed some of these letters, from A, B, C, D to like E, F, G, H. So they're very similar. And let's see how many questions is on here. Yeah, this one's a little bit longer than the actual test. The actual test is 11 questions and this one is 15. So the actual test is a little bit shorter than what you're going to see on the practice test. All right, so let's get into the questions. Now, just to reiterate, I am expecting that you're working on your own for the exam, but you may use any of your notes and any of our other course resources while working on this exam. And you are free to ask me any questions via email, and I will make sure and have my phone with me this weekend or next weekend, so that I can get back to you quickly. All right, so I just picked pretty much one of each type. For the proofs, I did 2, and then that way we'll have time at the end if y'all want me to cover anything else. We can do that. All right, so here we have, consider the pair of triangles below. We've got 2 triangles indicated here. We don't know the names of them yet. This one is telling us, this one on the left is triangle XYZ, but we have to name the one on the right. So this one is triangle XYZ. We don't know about this one yet. It says, name the postulate that proves the pair of triangles are congruent. So if y'all are looking at this, what do y'all think? What postulate would you use? We have side, 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 side angle, side.
Side, side, side.
Yep. Side, side, side. So each side has a tick mark on it. All right, so that's indicating to us that that's side, side, side. And then we're supposed to complete the triangle congruent statement, which just means that we need to go in here and match up and figure out, okay, X on the left triangle corresponds to which angle over here on the right. So H, G, or J?
H.
J, you think?
H.
H. Okay, so yeah, X is in between the 2 tick marks and the 3 tick marks, so that is H. So it'll be H. What does Y
J,
correspond
G.
to? Good.
J.
All right, so people seem to kind of be polarized on that one. Some people are really quick at naming the triangles, and some people really struggle with that. So if you find that you, if that's something that you're struggling with, just let me know and I can, give you some more examples. No?
I'm sorry.
No, you're fine.
Okay, so when I look at this, I said, and I blurted out J. So why? Explain to a little more. Why would it have been H?
Yes.
Because I'm
Right,
looking
so-
at. Okay, so looking at your videos when I was doing homework for videos, it was like we match up the same size with the same tick marks. That's my clue. So when I looked at it and I said J, but it's H, what how did I look at that wrong?
So X.
You have to.
Okay, yeah, you go ahead.
Oh, I was gonna say you have to look at where the tick marks fall on the triangle because it's not oriented the same position as XYZ. So you have to use the tick marks. So for example, if you're looking at this triangle XYZ, the line XY has 2 tick marks. The line XZ or ZX has 3 tick marks. And YZ or ZY has 1 tick mark. So you're going to go by where the tick marks fall. So for X, X falls between the line that X falls between 2 tick marks and 3 tick marks at the apex or the vertex. So you're going to look at the triangle on the right and you're going to look at those 3 tick marks and the 2 tick marks and what falls at the vertex right there. That's H. That's sitting at the point between the 3 tick marks and 2 tick marks. I don't know if I'm making sense to you.
Does that help? So, like,
Okay,
what we're
so
saying
like
is,
when I'm looking at the first triangle, okay.
Mhm.
So even if what I try to do is guide myself by the tick mark, the number of tick marks.
Mhm.
Okay, so when I look at that, I see it's resting, the 2 tick marks on this side is resting between X and Y, and it's saying that it's XYZ. So when I went over to the other triangle, I just want you to see my lens of how I looked at it instead
Yes.
You're
of
looking at the line, but you can't look at just the line. You have to look at what falls in between where. So even though the line has 2 tick marks, you have to use both of them, not just one. So even though XY has 2 tick marks and JH has 2 tick marks, where does it fall though? So you're going to use the 3 tick marks to help to guide you to find where it falls. So when you look at the line that has 3 tick marks, you realize that H falls in between the 3 tick marks on one side and the 2 tick marks on the other side. At that point is where H is sitting. And on the other triangle, the point between the 3 tick marks and the 2 tick marks is where X is sitting. So those two correspond because they're sitting at that point between 3 and 2. You get it?
yes, ma'am.
You feel that? Does that really help?
I mean, it yes, ma'am, it helps, but it's
I do see what you're saying.
No, I mean, just it's just like when I was doing the 2.2 homework quiz
Uh-huh,
last night.
uh-huh.
It's like you had options of rather just like some was HJG or GJH. You know, you kind of had them, and I thought you had said that it didn't matter what order they came in, but this
So
particular thing.
it really doesn't, and it does not matter how you name the first one. So
Okay.
like they may have randomly just named this XYZ. So it
Okay.
doesn't matter how you name the first one. It's the second one that matters. So the second one has to correspond to the first one. So,
Okay.
if you came in here and named this triangle on the left, if you said, okay, well, I don't like XYZ, I'm going to name it YZX, that's fine. You just have to rename this triangle on the right so that it matches the new name that you've given it. So yeah, there is some parts of it that don't matter. That is true. It doesn't matter
Because
how
I'm
you name the
saying,
first
like,
triangle.
if I like on the test, if I would have named that JHG or something like that, it still would have been wrong because I read it incorrectly. Is what
Right,
I'm trying to get
right,
myself correct on that manner.
right. And so
Okay.
that's why I am always going to name one of the triangles for you, because that's going to tell you, okay, this is the template that I need to be following when I name the second triangle. So I will always name one of the triangles for you so that you have something to go off of for the second triangle.
Yes, ma'am. Thank you.
Okay.
Thank you, Natasha.
All right. So here, same type of question. I just wanted to do another example because side can be pretty easy to spot, whereas some of these where you have a combination of sides and angles can be a little bit harder. So we have, consider the pair of triangles below. We've got two isosceles triangles. We've got two sides and an angle marked on each. And it says, name the postulate that proves the pair of triangles are correct. So again, our four postulates are side, angle, and angle. Did I say angle, side, angle? I meant to say angle, side, and then angle, side, angle. All right, so what do y'all think when you're looking at this?
Side angle side.
Good, side, angle, side. So two sides and an included angle. So B here is an included angle. Is side, angle, side. All right, and then we're supposed to complete the congruent statement. And it's off of here. Okay, complete the congruent statement. Triangle OBS is congruent to
FHD.
Good job. So F being the one that starts in between the blank side and the side with two tick marks, just like O, blank side and side with two tick marks. And then it goes towards the angle that's marked. So towards the angle that's marked, and then down the other side. So FHD. HD. Okay. That'll be the first question on the test, and it'll be set up just like this, where it's two parts, where you name the postulate and then complete the congruent statement. All right, so feel free to make your own little formula sheet, as you're preparing for the test this upcoming week. You might want to, collect all of the definitions on one piece of paper. So all of your postulates, maybe some examples where you're naming triangles like this. All right. So feel free to create, your own little formula sheet of sorts. All right. So here we have a proof. On the test, you're going to have two types of proofs. Some proofs will be multiple choice, like this one is, and some proofs will just be blanks, and you will have to fill in the blank. All right, so I tried to do a combination of both types of problems. And I really feel like that if you copy down all of the proofs, if you have them right there with you while you're working on the test, then there shouldn't be anything that's brand new that you're seeing on the test. It was probably all proofs that we've done before. All right, so we're given a lot of information here. And notice that there's nothing marked on our diagram. So we're going to have to go in here and mark some stuff. All right, so it says line segment AC is perpendicular to line segment DC. All right, so perpendicular means it's going to form a right angle. All right, so let's see. AC is perpendicular to DC. All right, so that forms a right angle right there. All right, so we've taken care of that. Next, it says AC is perpendicular to AB. All right, so AC and AB are perpendicular, so they also form a right angle there. Okay. And then the last part that we're given says that the line segment AB is congruent to the line segment DC. All right, so let's mark that. I'm going to do 2 tick marks. You could do 1 tick mark, do 3 tick marks. It doesn't matter. Just as long as both of the line segments have the same amount. All right, so that part's taken care of. All right, there's one more thing that we can mark here that's congruent to itself. Y'all see what that is? Which of these?
The perpendicular line.
Yep, the perpendicular line right here. That one is congruent to itself. So that's part of both triangles. So you can see it is part of this triangle on the left, and it's also part of this triangle on the right. So we're just indicating there that it is perpendicular, or excuse me, not perpendicular, it is congruent to itself. See if I can fix this real quick. All right, right angle, congruent, congruent. Okay. All right, so now we've got our diagram all marked up. Now we can look at our proof. Oh, and we're supposed to be proving that triangle DCA is congruent to BAC. Okay. So first line segment AC is perpendicular to line segment DC, and then line segment AC is perpendicular to line segment AB. What would y'all answer here? What's the reason for that?
Given.
Yep, that is given to us. Does everyone see that that's given at the beginning? All right, the next line says angle DCA, so DCA, that's that angle there, and CAB are right angles. What allowed us to mark these two angles as right angles? Was that the definition of perpendicular, the symmetric property, or the definition of an angle bisector?
Definition of perpendicular.
Yes. Because those lines were perpendicular, they formed 90-degree angles or right angles. So that was, this line here is because of the definition of perpendicular. So right now we have given and then definition of perpendicular. So just using the symbol there. The next line, we've got our blank under the statement, and it tells us that the reason is the right angle congruent theorem. All right, so we're supposed to tell which of the angles are congruent. All right, so they told us those, right? They said angle DCA and angle CAB. All right, so that was our right angles, DCA, CAB. All right, so DCA and CAB, that's option B. All right, so you're just using what's already in the proof to inform you of what the next line should look like. It's congruent to angle CAB. Okay. All All right, next we have the reflexive property. Remember, reflexive property is when something is congruent to itself. So what line did we
AC
say
is
was congruent?
congruent to AC.
Yep, AC and AC. That one was congruent to itself. So anytime you see the reflexive property in a proof, you want to look for the side that is shared between two triangles. So look in your diagram and see, is there a side that is being shared between two triangles? And that typically will tell you what you're using the reflexive property on. All right, so that was AC congruent to AC. Okay. All right, so next line. Line segment AB is congruent to line segment DC. How do you know that?
That was given.
It was, yeah. So make sure, and you could do this at the beginning of the proof. You could go through and look at all the statements and go ahead and mark which ones were given. Because that could definitely, trip you up if you were thinking, if you're kind of mid-proof and you're not expecting to see another given this late in the proof. So feel free to do that at the very beginning to go through and look and see what all is given. All right, and then our last line, triangle DCA is congruent to triangle BAC, and we're supposed to figure out which postulate we're using. So we've got, just looking at the triangle on the left, I'm going to just kind of mark this out here. Just looking at the triangle on the left, we have a side, an angle, and a side. So two sides, and the included angle is side angle side. Side angle side. So you want to make sure that you are copying this down, because I can guarantee you there's going to be something really similar on the actual test. See if I can get all this off of here. Angles, that was congruent to itself. There we go. All right, so you'll see a really similar problem on the exam. So make sure you get this copied down somewhere where it can, easily be accessed while you're taking the exam or working on the exam. All right, do we have any questions so far about the test in general or about the proof or anything? Okay. All right, so jump into a different type of problem. Got find the measures of the unknown angles W and Y. So here's W, here's Y. Now, what's special about W and Y that's indicated here? What do these two little tick marks mean?
Those are congruent.
Yep, those are congruent. Angle W is congruent to angle Y. All right, so those are equal. Now, on the last test, we had already talked about this, but all of the angles in the triangle have to add to 180. So U plus W plus Y has to add to 180. But if you know that Y is the same as W, well, let's just let both of them be W. And they told us that U is 50. Right, W plus W is 2W. Now we can just solve for W, and that'll tell us what Y is as well. So subtract 50 from both sides. 2W equals 130. So W is, what's that, 65?
65. I have a question, Dr. Berry.
Uh-huh.
For this particular kind of question, do we lose points? Because when I do this on my own, I don't do it the algebraic way like you just did it, like making the letters a part of the equation. I just do, if I know that these two angles are congruent and I have a given angle, I just
Yeah.
say 180 minus 50 equals 130 divided by 265.
Yeah, that's fine.
Okay.
That is totally fine. As long as you're showing your work, it doesn't matter to me what way you do it.
Okay.
So if you didn't have this marked here, so if you didn't see any little tick marks here, you wouldn't have been able to solve this. So the only reason we're able to solve this is because they are specifically telling us that W and Y are the same value. All right. Similar problem. Find the values of M and N. This is really a little bit of review from what we did in the last test. Let's see here what we've got marked. We've got a right angle. We've got two triangles, right? We've got this little right triangle here on the left, and then on the right, you've got this isosceles triangle. You've got a right angle marked here. We don't know what M is. We don't know what this angle is. But we can figure out what this little angle that I marked in green is, right? Because what is this form? You remember what that's called?
A reflexive, a supplementary angle.
Yes, that's right. A supplementary angle. Supplementary. Or a linear pair. And we know that those two angles have to add to 180. All right, so if 140 plus this chunk is 180, the little chunk must be 40.
40.
Okay, so now looking at the triangle on the left, we've got a 90-degree angle, 40-degree angle, and M. So now you can figure out what M is. So you've got 90 plus 40 equals 130. You subtract that from 180.
50 degrees.
Good. All right, so M is 50. Now we got to figure out, now we have to figure out what N is. All right, so we're just looking at this triangle on the right. Right. Oh, okay. So because this is an isosceles triangle, I'm just going to kind of try to redraw it here. Here's our isosceles triangle. If y'all remember the base angle theorem, it said that if you've got an isosceles triangle, then the angles that are opposite from those sides, so that would be this angle here and this angle here, those angles have to be equal.
Mm-hmm.
All right, so those
So
angles must be
20.
equal. So that's going to add to 180. Let's call this X. Or actually, let's call it N. That's what they called it. My bad. So 140 plus N plus N. And again, if you're doing this a different way, that's fine. 2N equals 1. Let's see if we subtract 140 from both sides. Gives me 40. So N is 20.
20. Mm-hmm.
There's one just like this on the test, just different number instead of 140. So you will essentially just go in here and, at the very beginning, you'll change, instead of 40 degrees, you'll have a different value here, but everything else will be done the same. So just with new values. So that's almost half the test that we've covered so far. Next, we have another proof. See if I can move this. Okay. The 2-column proof. Here we've got another longer fill in the blank, or no, sorry, multiple choice proof. And also notice that all the blanks are under the reasons. All right, so I'm not sure if that makes a difference to you guys, but I tried to put a combination of both. So I put some on there where all the blanks were on the reason side, and then I put some where it kind of went back and forth. So it says you're given a bunch of information here. HK is congruent to LG, all right, and that's already marked for you. Do y'all see that? Those little tick marks. And then it says HF is congruent to LJ. That's already marked for us as well. And then FG is congruent to JK, which is already marked. And we're supposed to prove that the triangles are congruent. And we know that anytime we're proving that triangles are congruent, we know that we're going to have to use one of our 4 postulates. So at some point, we know that we're going to be using, side side, or side angle, or side side side, something like that. All right, so first line of the proof says HK is congruent to LG, HF is congruent to LJ, and FG is congruent to JK. And that's already given to us. And they've already filled that in. So we don't have to do that part. Right now, they've got some different notation here that you may not have seen in a while. I know we talked about it before the last test, but it just says HK equals LG. That just means the length of HK is equal to the length of LG. All right, so when you see that notation where they have just the letters, no line segment notation over it, then that's the length of that line segment. All right, so let's look at our options here. Our options are addition property of equality, definition of equality, reflexive property, definition of congruent segments, transitive property, or segment addition postulate. So which one of those sounds right?
Definition of equality.
And you're almost there, but just think about up here on this line. This is not an equality. That's a congruence. So you're almost there, but it is definition of congruent statements, congruent segments, not equality. So very close. But because that was
I struggle with these.
Congruent instead of an equal sign, that's why they do that one. Okay. Next line. KG is, the length of KG is equal to the length of KG.
Reflexive.
Yep, reflexive. Anytime something is congruent to itself. So this is definition of congruent statement. Segments, sorry. And then next line is reflexive. Sometimes it helps to see the proof filled in. All right, this one, I remember this line really messed people up the last time I taught this class. But just look at what they're doing here. Remember, these are line segments. These are lengths of line segments, and they have HK plus KG is LG plus KG. So they're really just adding together the previous 2 lines. And look at your options. Addition property of equality. Then we have definition of equality, a definition of congruent segments, transitive property, segment addition postulate, or reflexive property. So because we are adding segments, I would say this is the segment addition postulate. Does that make sense? But I also feel like addition property of equality would be okay too. So this one is okay too. But I would say this is the segment addition postulate. And we saw that back in section 2.1. So it's been a while since we've seen that. All right, next line. HG is equal to LK. All right, so let's look at, where did that come from? Okay, so look at the previous line and look at HK plus KG. HK plus KG. That gives you HG. All right, so this side is equal to HG. And then this side is equal to LG, let's see, LG plus KG. Erase that, start
Is
over.
it congruent segment?
Yes. Yes, I would say definition of congruent segments. Let me look at this real quick. Segment addition postulate. Say, I still want to say segment addition postulate because that's really what we just did. Think about it for a second. Segment addition postulate or definition of congruent segments. Okay, I think I know what I want to do. I think I want to go back and change this and make this addition property of equality because I don't want to use that twice in a row. So I think I would make this one addition property of equality. Would make the next line the segment addition postulate because that's really what we did is we just took two segments, added them together, and made them into these two new segments, LK and HG. Obviously, this one is not on the
confused.
I'm sorry. This one is not on the test, if that makes you feel better. All right, so on the third line or the third blank, what we were doing is, let me go back and erase this. Okay. So on the third line, we took line 2 and we added kg to both sides. So we said HK plus kg, LG plus kg. So I'm saying that's the addition property of equality because you're adding the same amount to both sides. And then in the next line, you're converting this to its new name. So HK plus kg. So HK plus kg gives you HG. So if you put those two line segments together, they form the big line segment HG. And then LG plus kg gives you LK, the big line segment LK. And so I'm saying that's the segment addition postulate. So line 4 is the addition property of equality because you were adding the same amount to both sides on line 2. So you took line 2 and added the same amount to both sides. And then for the next line, we're calling that segment addition postulate. All right, and then line 6, which is the fifth blank, HG is congruent to LK. HG is congruent to LK. C. HG and LK. Erase this so we can look at what HG and LK is. Here's HG, it's the bottom of the triangle. Here's LK, it's the top of the other triangle.
No, it was later.
Congruent
So what we
segment.
did is that we took one congruent segment and added the same amount. Take one congruent segment, added the same amount. So we've created two congruent segments. So that's still the definition of congruent segments. So definition of congruent segments. So what we really just did is we went from here to here, and you're just saying, okay, if the length of two segments is congruent, then the line segments are congruent. So if length is equal, line segments are congruent. That's what you're saying. All right, so definition of congruent segments. All right, and then the last line, triangle FGH is congruent to triangle JKL. All right, so
Side.
Yep, side, good. Side. Okay, I think I've got this marked. Let me fix it. segment addition. This one is definition. Okay. Okay. And let's look at these. I want to say these are worth 10 points. I've got 2 of these just like here, and they're worth 10 points on the test. Given the figure below, use the lines M and N with the transversal T to select the answer that completes the sentence below. All right, so angle 4, let's mark that. Angle 4 is an alternate interior angle with what other angle? So we're looking in between these 2 lines. Remember, it's interior, so it's got to be in between those 2 lines. So what is the alternate
Angle
interior
10.
angle? Yes,
Angle
angle
10.
10. Good. So alternate means it's on either side of T. Interior means it's in between M and N. So alternate means on either side of T. Interior means between M and N. All right, so now we're looking at corresponding angles. Corresponding angles are like on the same side of the line. Fix that. There we go. And we're saying angle 14, which is right here. All right, so it is above N. So we need to go to our other line M and go above M. All right, so that'd be angle 6.
Mm-hmm.
All right, so corresponding, you want to think it's on the same side of the line. All right, so same position, just the other parallel line. All right, so that one hopefully will be easy 10 points. All right, and then last one. I really like this question. I want to say I made it, don't hold me to this, but I want to say I made it maybe 10 points on the test. Find the value of X for which M is parallel to N. Right, so that double line there means is parallel to. Right, so here we have M and N, which are parallel. So this is our parallel lines. Right now, we don't have either of our special angles that we've talked about. These are not corresponding angles. They are not alternate interior angles, but we can work with this and we can make them into one of those. We know that this transversal is a straight line. So here, that forms a supplementary angle or a linear pair. So you can say, okay, 180 minus 93. Let's see, what is that? 87. Yeah, 87. All right, so this is 87 degrees over here. And now these are alternate interior angles. So now these 2 are alternate interior angles. They're on either side of the transversal and they're in between the parallel lines. So they're on either side of the transversal and they're in between the parallel lines. So these are alternate interior angles. And we know that alternate interior angles are equal or congruent. So we'll just set these guys equal to each other, those 2. So 3x minus 18 equals 87. Then we'll just solve for x. So add 18 to both sides.
35.
Is it 35? Is that right? Yes. Yeah, so add 18, that gives you 105, then divide by 3, that gives you 35. So x is 35. Okay. I'm going to jump over, let me see what time it is. Okay, we have about 8 minutes. I wanted to jump onto the 2.3 homework real quick. How has everybody found the homework? Did you feel okay? Yeah, we have not a lot of people that have done this one yet. Let's do a preview. Okay. So M and N are the parallel
With
lines.
this, I'm sorry, Dr. Bear, with this homework, number 8, there's no diagram for it. I
Oh,
literally
yeah.
guessed that answer.
Fix that one. I might have the PowerPoint where I've got all the diagrams in there. So I might be able to fix that. If I can't fix it, I'll take it off. But let's look at these. So how do are y'all feeling like nervous about these ones or more nervous about the proofs?
I'm definitely more nervous about the proofs. These
Yeah.
I were okay. I was okay with these.
Yeah.
They're manageable.
Yeah, I think the more you practice these, the better you'll get at them. I'll just do this, maybe a couple from this one, and then I'll go look at the proofs homework. All right, so M and N are our parallel lines. T is our transversal. You can totally ignore Q for this question. And we're supposed to find the corresponding angle with angle 4. So what do you think? It's below M, so it should be below N. What do you think is the corresponding angle for 4?
12.
Yeah, 12. So it's below M, below N, in this bottom left corner, bottom left corner. And let's look at, oh, and for these, I did want to mention, if you see something like this, like alternate exterior angles theorem, we didn't talk about that, so that can't be the answer. All right, so let that help you eliminate answer choices. Same side interior angles theorem, we didn't talk about that, so that can't be the answer. So it's got to be one of these bottom 3. All right, and then we just did this one, so I think that's fine. All right, hopefully that one's okay. Let me look at the proofs one. Now, the only thing that I don't like about this, about doing this on D2L, is that, you don't see it being filled in as you go. So you're not seeing, like, once you choose given, you're not seeing that pop up in line 1. So I would encourage you to copy this down on your own paper and fill it in as you go to help you with that. Let's see. I know for sure that this one is going to be on the test. So this is question number 4 on the 2.2 homework. This one is definitely on the test. So make sure you're copying this stuff down. In fact, I would probably just copy down all the proofs and, have them written in a notebook or something. And that way, if you find one on the test that matches one from the homework, you've got it right there. And you can easily reference it. And the only difference might be that the letters are different. So instead of A, B, C, D, it might be E, F, G, H. But you can easily match up the letters and figure that out. All right, so of course the first line is given. So we have this diagram here, and it gives us some information about the angles, and it just copies that down into line 1. So line 1 is given. Let's look at line 2. Line 2 says line segment BD is congruent to line segment BD. What is it? What's the property when something is congruent to itself?
Reflexive.
Yep. All right, line 3, triangle ABD is congruent to CBD. And remember, we just marked this as congruent. So I can't mark it on the screen, but if you were drawing this on your own paper, you would put a little tick mark there. So looking at the triangle on the left, this would be angle, side, angle. So line 3 would be angle, side, angle. And then remember, anytime you're doing one of the 4 postulates, the next line that follows that is almost always going to be CPOCTAC, which is corresponding parts of congruent triangles are congruent. And that just says that, okay, once you know that these 2 triangles are congruent, you can match up everything. You can say AB is congruent to CB. You can say AD is congruent to CD. And so it just gives you all this information for free. All right, so that's what line 4 is. AB is congruent to CB, so that's CPOC-TAC, or corresponding parts of congruent triangles are congruent. This one, I don't think I put this one on the test. I'm not recognizing it straight away, so I don't think that one's on there. Let's see. This one looks familiar, so because I just wrote the test, so I'm thinking that this is on there. You can see it's a pretty short proof. Says you're given the AC is congruent to EC. So these two long line segments are congruent. And then CB is congruent to CD. And you're supposed to be proving that angle A is equal to angle E, or congruent to angle E. The first line, of course, is given. So that information was given to you. Yeah, that was line 1. Line 2, angle C is congruent to angle C. What is that when something that's congruent to itself? Reflexive, right? Right, and then line 3, you're supposed to fill in the blank with the name of the triangle. So triangle ACD is congruent to, so ACD would be ECB. Right, so ACD. I'm just kind of imagining these triangles in my mind. I'm trying to like separate them in my mind. So you can see there's the triangle there. There's its leg, there's a leg, there's a leg. And then for the other one, similar. So they're just like two overlapping triangles. All right, so we said that was going to be ECB. ECB. And then line 4, angle A is congruent to angle E. Again, after you use one of the 4 postulates, you're almost always going to do CPOC-TAC. All right, so
Dr. Berry.
Mm-hmm.
Okay, go back to that when I was talking previously. See all of those versions right there.
Mm-hmm.
It's like it's got EBC and ECB. It's like that's a problem that I had to do more than one time.
Uh-huh.
But the order that they're in.
Let me copy this over so that I can write on it on my screen. See if I can find it. Okay. Those my kids. All right. There we go. Okay, so they called the first one, let's see what they named it. ACD. Okay, ACD. Angle ACD. All right, so here's the first one. The first one. Okay. Now we have to look at what they told us. They told us that angle C was congruent to angle C. All right, so we can mark that on here. This angle is congruent to itself. All right, let's see what else they told us. AC is congruent to EC. So AC, that's this line here, is congruent to outline this triangle. It's congruent to this line.
And I'm sorry, I don't want to take up go over time.
Yeah. If anybody needs to leave, that's fine. I'm gonna finish this up and then I will end the recording because I got to prepare for the algebra live session. But I'll finish this one up. So I know my picture here is terrible, but you might want to consider like redrawing them separately. All right, so this is C, A, D. This one is E, C, B. So all I did was I just copied down these triangles and wrote them separately. Okay, and then we had one extra piece of information that I'm missing. side angle. CD. What am I missing? Oh, okay. CB to CD. No, I had that. Oh, yeah. Okay, that was what I was missing. CB is congruent to CD. Okay, so now we see we have side, angle, side, and now we can name the triangle. We have ACD. A is the angle that is in between the blank side and the side with 2 tick marks. So the blank side and side with 2 tick marks, that corresponds to E. All right, so A matches with E. Then you go, okay, the next one was C. C is the angle that's marked. On the other triangle, C is the angle that's marked. All right, so C matches with C. And then on the last one, D is the angle that is in between the side with 1 tick mark and the blank side. So the side with 1 tick mark and the blank side is B. So you have to fill in the diagram and then, kind of do what I've done here. If you need to, some people may be able to get this without redrawing the stuff. But if you need to, you can separate them into 2 pictures, redraw them, and then kind of match them up the same way we were doing in number 1.
Yes, ma'am.
That makes sense. Okay.
Is the 5-point thing for the practice test still available for this test?
Yes.
Okay.
I'll still do 5 bonus points if you turn in the practice test.
Okay.
And make sure the only last piece of advice I'm going to give you is that make sure that for every problem you write down something. So even if you don't feel confident and you feel like, oh, I know this is definitely not the right answer, at least put down something so I can give you some partial credit, and write down like what your train of thought is so I can try to follow along and give you as much partial credit as possible. This is going to be hard. It's not, I don't want to, act like that it's, going to be, you're going to breeze through it. It is going to be hard. But I think that if you use the resources that we have in our course, if you ask me questions, and if you, get all of your information kind of, collected into one place and have it neatly organized, I really think you're going to do okay on the test. All right, I'm going to let you guys go, but if you have any questions, we have a whole week to prepare for the test. So anything you need in between now and then, if you need me to make more videos of me going over proofs, anything you need, just let me know and I can make that happen. All right, you're welcome, Jessica. I'll see y'all next time. Have a good day.
All righty,
Bye.
thanks.
Thank you.
Thank you.